Welcome to our Predictive Targeting Part 2 video in Marketing Accelerator demo in Alteryx. Predictive targeting is a subset of predictive analytics that uses artificial intelligence, statistics, and customer data to predict what a customer might want or need in the future. Its goal is to show the right product to the right customer on the right platform at the right time with advertising. Our approach is very simple and based on 3 tenets. 1. Earn trust. 2. Be business outcomes focused. 3. Execute flawlessly. In the previous part, we explored different aspects of our data. Now, we'll continue by connecting and configuring additional tools to gain further insights. First, we'll connect the output of the formula tool to the first select tool to select the field's age and interest. Then, we'll use the unique tool to extract the unique values for these fields. By using the Browse tool, we can view the output and examine the unique values for age and interest. Next, we'll review the distribution of spending across different age groups. To do this, we'll connect the output of the formula tool to the second select tool and select the field's age and new spent, renaming them as spent. Using the interactive chart tool, we can create a boxplot visualization with age on the x-axis and spent on the y-axis. By using the Browse tool, we can observe that there are outliers in the 30 to 34 age group, suggesting higher spending despite targeting the 45 to 49 age group. Now, let's move on to reviewing the spending distribution based on gender. We'll connect the output of the formula tool to the third select tool, selecting the field's gender and new spent, and renaming it as spent. Using the first summarize tool, we'll group the data by spent and gender to analyze the distribution. To visualize this, we'll use the third interactive chart tool with gender on the x-axis and spent on the y-axis. By using the Browse tool, we can observe that despite targeting more males, the organization spends more on the female audience. Moving forward, let's analyze the spending distribution across specific campaigns. We'll connect the output of the formula tool to the fourth select tool, selecting the field's XYZ campaign ID and new spent and renaming them as spent. Using the second summarize tool, we'll group the data by spent and XYZ campaign ID to examine the distribution. To visualize this, we'll use the fourth interactive chart tool with XYZ campaign ID on the x-axis and spent on the y-axis. By using the Browse tool, we can observe that campaign 1178 receives a significant portion of the organization's budget. Further exploration of this campaign can provide valuable insights into the overall Facebook ad placement strategy. Now, let's analyze the spending distribution based on interests. We'll connect the output of the formula tool to the fifth select tool, selecting the field's interest and new spent, and renaming it as spent. Using the third summarize tool, we'll group the data by spent and interest to analyze the distribution. To visualize this, we'll use the fifth interactive chart tool with interest on the x-axis and spent on the y-axis. By using the Browse tool, we can observe that there are outliers in interest 16 and 10. The majority of spending is on interests 100, 101, and 107, indicating a relatively even distribution of the overall Facebook ad budget. However, further investigation into outliers can improve the next quarter's Facebook ad placement strategy. To enhance our analysis, we'll create new features such as click-through rate, CTR, and cost per click, CPC. We'll use the formula tool to calculate CTR by dividing the number of clicks by the number of impressions and multiplying the result by 100. Additionally, we'll calculate CPC by dividing the amount spent on ads by the number of clicks. To ensure data cleanliness, we'll use the data cleansing tool. We'll replace string fields with blanks and numeric fields with zeros. We'll also remove any leading and trailing whitespace. Next, we'll explore the overall correlation between variables using the Pearson correlation tool. To visualize the correlation, we'll use the transpose tool to convert the horizontal data into the vertical axis. Using the Insight tool, we can view the correlation in detail. we can observe that there is a strong positive correlation between impressions, clicks, spent, total conversion, and approved conversion. To investigate the relationship between impressions and clicks further, we'll use the association analysis tool. It shows a strong positive correlation of approximately 0.94 between the variables impressions and clicks, indicating that as the number of impressions increases, the number of clicks also tends to increase. We will use Browse tool to view the output accordingly. Like above, we will then connect Select tool and select the field's impressions and clicks. To visualize this correlation, we'll use the Scatterplot tool with impressions on the x-axis and clicks on the y-axis. By using the Browse tool, we can observe the scatterplot and confirm the strong positive correlation between impressions and clicks. In order to look at Pearson correlation and p-value, we will connect Pearson correlation tool like above, where the Pearson value is 0.9485 and p-value is 0.0, which shows the correlation between impressions and clicks are expected as the more Facebook ads of a campaign displayed, the more users will click on the ads. However, the correlation is also significant and linear relationship is strong. We will use Browse tool to view the output accordingly. Similarly, we'll explore the correlation between clicks and spent using the association analysis tool. It demonstrates a strong positive correlation of approximately 0.99 between spent and clicks, indicating that as the amount spent on ads increases, the number of clicks also tends to increase. We will use Browse tool to view the output accordingly. We will now use Select tool and select the fields clicks and spent. Let's visualize this correlation by using the Scatterplot tool with spent on the x-axis and clicks on the y-axis. As we can see in the Browse tool, there is a strong linear relationship and significant correlation between clicks and spent. Now, let's focus on the relationship between campaign and click-through rate, CTR. We'll use the Select tool to choose the fields XYZ campaign ID and CTR. Using the Formula tool, we'll create a new field called New CTR of the fixed decimal data type based on the CTR field. To analyze the distribution of CTR for each campaign, we'll use the Summarize tool and group the data by CTR and XYZ campaign ID. Finally, we'll use the Interactive Chart tool to visualize the box plot, with XYZ campaign ID on the x-axis and CTR on the y-axis. Analyzing the output in the Browse tool, we can observe that while campaign 1178 receives the majority of the Facebook advertising budget, campaigns 916 and 936 show better consumer engagement based on through rate, CTR. Despite serving more ads for campaign 1178, the engagement is lower. Let's filter the data for campaign 1178 to review it in detail. We'll use the Filter tool with the condition XYZ campaign ID equals 1178. After filtering, we'll select the fields Spent and CTR using the Select tool. To examine the correlation between Spent and CTR on campaign 1178, we'll use the Pearson correlation tool. The correlation matrix shows a moderate positive correlation of approximately 0.35 between spent and CTR, suggesting that as the amount spent on ads increases, there is a tendency for the click-through rate to also increase. However, the relationship is not as strong as in the previous examples. We will use Browse tool to view the output accordingly. Let's use the Scatterplot tool to visualize this correlation, with CTR on the x-axis and spent on the y-axis. In the Browse tool, we can see the scatterplot, indicating a positive linear relationship between spent and click-through rate. This aligns with the organization's spending on campaign 1178, where there should be clicks on the ads. However, the correlation is relatively weak and could be stronger, considering the performance of other campaign ads like 916 and 936. Additionally, it's important to note that organic engagement also contributes to the overall click-through rate CTR. Now, let's create our training and test data sets. We'll use the Select tool to choose the fields Impressions, Clicks, Spent, Total Conversion, and CTR. To split our data, we'll utilize the Create Sample tool from the Preparation toolset. This powerful tool allows us to divide our dataset into training and test samples. We'll set the estimation percent to 70%, allocating 70% of our data for training the model and the validation percent to 30% for testing the model's performance. For prediction, we'll use the Forest Model tool. We'll configure it by selecting the target variable as total conversion and choosing the other fields as predictor variables. You can name the model as desired. Next, we'll connect the output estimation anchor of the Create Sample tool to the input of the Forest Model tool. To review the model's performance, we can add the Browse tool to the output reports anchor of the Forest Model. This allows us to examine detailed reports and insights. Now, let's predict the scores using the Score tool. We'll configure it by selecting the model type as Local Model. We'll connect the output validation anchor of the Create Sample tool to the input data anchor of the Score tool. Additionally, we'll connect the output output anchor of the Forest Model to the input model anchor of the Score tool. We can use the Browse tool to view the predicted scores in detail, examining how well our model performs. To focus solely on the total conversion and its corresponding score, we can connect the Select tool to the output of the Score tool and choose the field's total conversion and score. Finally, we'll use the Browse tool to view the output and gain insights into the predicted total conversion scores, and there you have it. We've successfully created our training and test datasets, built a predictive model using the Forest Model tool, and obtained predicted scores for total conversion. Be sure to check out the Browse tool to explore the results in more detail. Now, let's explore some business use cases for the predictive targeting model. 1. Customer acquisition. 2. Customer retention. 3. Cross-selling and upselling. 4. Personalized marketing campaigns. 5. Fraud detection. 6. Inventory management. Let's delve into the key findings from our analysis and draw some important conclusions. After analyzing the data, we found that the organization primarily targets consumers in the 30 to 34 age group, and there is a higher proportion of male audiences in their Facebook ads. However, interestingly, they allocate a significant portion of their ad budget to targeting females between 45 to 49 years old. This suggests a misalignment between the target audience and the current consumer personas. We recommend revisiting and refining the consumer personas to ensure better targeting effectiveness. Furthermore, we observed a positive relationship between ad spend and conversions. As the business invests more in Facebook ad campaigns, conversions tend to increase. However, we also noticed that campaign 1178, despite having the highest spend, received the least engagement. This indicates a potential issue with the campaign's creative or strategy. Additionally, we found that the overall ad spend distribution across different interest categories was relatively balanced, with interest 100, 101, and 107 receiving the highest amount. However, there were some outliers, particularly interest 16, 27, 28, and 29, which received significantly higher spending. We recommend a thorough review of these outliers to optimize Facebook ad placements. Moreover, we discovered that while there is a general positive correlation between ad spend and engagement across all campaigns, the relationship is weak. This suggests that other factors beyond just ad spend contribute to engagement levels. Therefore, we recommend revisiting the distribution of ad spend between campaigns to ensure a more efficient allocation of resources. Finally, regarding the predictive model developed, it is essential to conduct further evaluation and make necessary adjustments before implementing it for the next quarter. Continuous monitoring and refining of the model will ensure its accuracy and effectiveness in automating Facebook ad placements. In conclusion, our analysis revealed important insights for optimizing the Facebook ad campaigns. By revisiting consumer personas, refining campaign strategies, and optimizing ad placements, the organization can enhance its targeting effectiveness and maximize conversions. Additionally, a more efficient distribution of ad spend and continuous improvement of the predictive model will contribute to improved performance in the upcoming quarter. Thank you for joining us today, And don't forget to like and subscribe for more data-driven insights. Inquire about our complete Marketing Accelerators bundles. Follow us and like us on LinkedIn and visit our Marketing Accelerator page, www.fugetroncorp.com/marketing-accelerator. Thank you and see you soon for a live demo.